So today's speaker is Dr. Rob Serrouya from the Alberta Biodiversity Monitoring Institute. And Rob's name has been a fixture in wildlife ecology research in BC throughout my career. He did his undergrad at McGill University, and when I came out here to do my master's with Charlie Krebs, Rob was just finishing up his master's here in forestry, where he studied black bears in Banff National Park. And Rob went on to do his PhD at the University of Alberta with Stan Booten, where he worked on caribou conservation, some of which he's going to be talking about today. Rob has become a real expert in large mammal predator-prey dynamics in Western Canada. And like many of us who are foolish enough to try and study large mammals, Rob's faced the challenge of how to do experiments on these wide-ranging and often elusive species to try and get stronger inferences. But unlike many of us, Rob has actually achieved a lot of success in working with managers to try and implement adaptive management on the ground and try and make some of these big experimental inferences. So Rob now directs the Caribou Monitoring Unit at the ABMI, where he's responsible for a large number of research projects that try to better understand caribou dynamics and try and increase our hope for actually saving this threatened species. And even though the ABMI is based out of Edmonton, Rob likes to joke that he's set up the Revelstoke campus of the ABMI because he's based in Revelstoke. And he assures me that has nothing to do with the fact that it's the largest vertical ski resort in North America. So with that, I'll hand it over to Rob.
Thanks, Cole. I like the cookies too, by the way. So far it's really fun to be here. A lot has changed. I was embarrassed that I had to use Google Map to navigate the campus. Like 22 years, a lot has changed. But I'm also comforted to see that some things are the same. This morning I lectured in Cole's undergraduate class, and two undergraduates absolutely nailed me with questions. It was awesome. Thankfully they kept it to after the class, and then it's going to sharpen my mind for this one here because they pointed out a few things that I did not explain well. And yeah, it's heartening to see that. Whenever I prepare one of these kinds of seminars, it makes me think back and really recognize the accomplishments that my predecessors have made. These folks clarified the causes of decline of woodland caribou over the last 20 or 30 years, but by the time I came on the scene, let's say in about 2000, I said, okay, folks, we have so much data on caribou. It's probably the most studied endangered species in North America. Let's sharpen our minds and start to think of what levers we can pull, what recovery options we could pull. So my interest wasn't that academic at the time. It was simply let's test some recovery options and see what we can accomplish. And yeah, that involved hours and hours, like hundreds and hundreds of hours meeting with managers, meeting with the public, meeting with people and having workshops. And you are in the trenches doing this stuff. When you have 400 loggers yelling at you, you have people whose livelihoods are at stake. It's a very, very complex issue. And I almost would argue that it's one of North America's greatest terrestrial conservation challenges. So as well as thinking about my caribou predecessors, I also think about two of my favorite ecologists. I like many ecologists, but for the work we've been doing the last decade or so, you look back and we really draw upon the principles that these two gentlemen have established for us. And Graham Collier was a Kiwi, and he really helped us think about how to recover an endangered species. His question was, how do we address the factors that are suppressing demographic vital rates? Think about them, experiment, remove the limiting agent, remove the agent of decline, and proceed as best you can. And if it doesn't work, try again. Buzz Halling, a UBC graduate, in the early years of my career, I really appreciated his work with foraging theory, foraging efficiency. He helped clarify how a predator's foraging efficiency changed with prey density, though otherwise known as the functional response, and I think a lot of us have used those concepts in our population ecology work. And then Buzz started to become very interested in ecosystems and how they respond to perturbations, and helped teach us to use management as an experiment. Now, there's different degrees of learning when you experiment with management. Sometimes you can't do treatments and controls, sometimes you can't replicate, sometimes you can only use a time series approach, but really you have to formalize the process and, Clarify your thinking instead of panicking and using trial and error. And I'll give a couple of those examples, of course, because that happens all the time. And the other component is that if you make a mistake at an enormous scale, sometimes it can be irreversible. So let's use computer models to try and buffer against those mistakes. Let's forecast using the best theory we've got. So yeah, back to Graham. So his steps were fairly basic. Determine the cause. Easier said than done, but do that. Remove the agent of decline. He actually specifically mentioned transplant the organism to try and recover its population, then monitor the response. And if I integrate the thinking of several different ecologists, bring in the idea of adaptation, bringing back iteration, I should say. Iterate the process. If you haven't got it right, keep going. Now, I think caribou exemplify these challenges more than most other critters. As Graham Collier also pointed out, he classified different conservation challenges. And one of them was if a species is naturally rare and broadly distributed, you've got the biggest problem. Like, for example, at the opposite extreme, let's say you've got the Banff Springs snail. Protect 2 hectares, you got the whole worldwide distribution, tickety-boo, you're done. When it comes to caribou, especially woodland caribou, we've got 5 different subspecies on the continent, but woodland caribou here that cover millions of square kilometers. Their habitat needs overlap with billions of dollars of oil, millions of dollars of forestry. You've got a recipe for probably one of your biggest challenges you can face. So it's really a complex problem. And often we get teased about this. We try and summarize our state of knowledge, very simply, while Rome is burning, people think that, we're just twiddling our thumbs. And this came out in my local newspaper in Revelstoke in 2006, and I thought it was funny. But, yeah, I'll try and convince you that this is not true. Well, it's partly true. We'll see. Yeah. So why are caribou declining? At least woodland caribou, that most southern subspecies. Well, the story goes something like this. Bob Holt called it apparent competition. It appears as though 2 prey species compete, but really their population dynamics are completely decoupled. When you have an invading prey species, so these critters all occurred off of California on the Channel Islands. These feral pigs were introduced. It caused the establishment of eagles. Eagles then were driving the Channel Island foxes to extinction. And this is the undergraduate question after the lectures. Well, what do you mean? How can that be? You haven't, why isn't there some kind of feedback here? And the detail I forgot to mention was that these animals are far more fecund and resilient to predation than these animals. And that's the same, that's what disrupts the equilibrium. There's basically a complete decoupling. The predator numbers are not at all coupled to this prey, so the prey can be driven to extinction. And the story is very similar with caribou. So you have an increase in moose and deer in western North America, more wolves and cougars, and caribou essentially become bycatch. The added twist, which really complicates the story, bycatch. The added twist is the habitat modification. These animals were not transported there. They weren't introduced. We have basically forestry that replaces old-growth forests with shrubs. The shrubs provide an enormous amount of forage biomass for these herbivores, which then creates the increase in these animals. And yeah, so that's the challenge. And yeah, the forest legacy is very problematic. This narrative has been told time and again now across the country. So it's something that's being uncovered by independent research labs across the country. The data quality has increased over time. The earlier stories were maybe less secure, less straight. But as time's gone on, we've solidified the story. But I don't want you to take my word for it. This is sort of scientific name dropping. Let's take a step back and be a little bit more critical than just listing a bunch of names. Why don't we contrast 2 hypotheses and see how they hold up against the data? So, the 2 hypotheses would be food regulation versus apparent competition. Food regulation is basically density dependence 101. It's a basic density dependence. As a population decreases in density, there's more food per individual. As you have fewer individuals, there's more food per capita. And what that should do is stimulate a vital rate, whether it's survival or reproduction, to increase such that your per capita rate of increase is higher when you have fewer individuals. So this is your hypothesis, this is your prediction, and the dominant source of mortality would be expected to be malnutrition. To contrast that hypothesis with apparent competition, recall that I said that the numbers are decoupled. There's no coupling between the predators and prey. So you would expect a density-independent rate of increase driven by a density-independent predation rate. And you may even get inverse density dependence, otherwise known as an Ali effect. So this work was done by Heiko Whitmer, a PhD student here in forestry, Tony, of course, and also supervised by Bruce McClellan, a Ministry of Forests researcher. Charlie encouraged me to rant when I talked with him this morning, but of course I'm nervous because they want to put this thing on YouTube, so this is why I never get hired by the government when I start going this way. Bruce was, there's like a 60-year tradition in the research branch of the Ministry of Forests of hiring PhD researchers. And in 2009, they disbanded that. It doesn't exist anymore, and they don't hire PhDs anymore. And that's too bad, because we had a nice tradition there of applied work integrated with universities. So we contrast those data with those hypotheses with data. These are 18 different subpopulations, and we sure seem to see that those with the most food per individual are declining at the fastest rate. And predation caused most of the deaths, and probably, I know that although not all the deaths were predation, of course, a lot of them were unknowns because you get there too late. And I think this story must be right because Charlie reproduced it in his textbook, so, Okay, so maybe I've convinced you of something. So now, let's get back to this slide and focus on the recovery options. Okay, well, we could protect habitat. We could do nothing else than protect habitat. The problem with that approach is it's going to take decades for recovery because of the legacy of forestry. These shrubs will be here for 30 to 50 years, which will keep the trophic interactions going. In contrast, you could kill predators, and we've done that. That's been done in the Yukon. It's been done everywhere. Not always for an endangered species, but it's been done. It's a Band-Aid solution because the moment you stop, the predators come back because there's still a lot of this biomass. And it's increasingly unpopular, of course. The other option, and this one is sort of new, and it's what I tested as part of my PhD work, was what about an intermediate approach? It seems to be less politically unacceptable, but reducing these invading prey species and understanding how that influences predator numbers indirectly and how that might affect caribou. And on top of these options and on top of all the science, we have values. Values trump everything, really. I'm told this is Miley Cyrus. She's been in BC a lot lately and protesting wolf culls and logging and all that kind of stuff. I mean, things have changed since these wily old dudes would be out shooting grizzly bears and wolves and such. It's a different world, and the levers are changing all the time. The opportunity to do levers. I'm gonna over the last 2 or 3 months, I tried to consolidate all the management experiments that have been done in Western Canada. Again, some of them have varying degrees of quality and thought, and and I think I made this next slide this morning because I realized I didn't have. Some jargon. Lambda, again, Graham Colley. If lambda is 1, for people who aren't population ecologists, that means stability. It's the finite rate of change. 1.05, 0.95, pretty basic. So these are lambda values across Western. I made this slide this morning and I got depressed. I mean, you don't get into this business if you're a pessimist. Like it is not that optimistic. But let's start to pull some levers. Okay, so we have wolf control, one of the options I discussed earlier. This has been going on in Alberta for a decade and a half. In BC, this one's brand new here. It's got a treatment and a reference area where wolves aren't being reduced, and then there's this one down here that also just begun a few years ago. Moose reductions. This one is the one I worked on for my PhD, and this is the one that my colleague Doug Hurd implemented in Prince George. Again, yeah, these management levers come with enormous social costs. I mean, I regularly run into the guide outfitter here. I mean, who lives here? He lives right in the bush. And yeah, we have destroyed his business by reducing moose. There's no question. It's very difficult. And then all the forestry constraints to harvesting. It's a messy business with enormous social costs and efforts to implement. There's also, let's call them trial and error, some panic approaches. Caribou were brought down from the level Coddy herd down to the Purcells in 2012. And I don't even have to show any caribou lambda values here because the moose reductions. So we'll start with Prince George. And again, I'm giving a very broad overview right now. I'm going to dive into some of the mechanisms. This is more pattern than process. But yeah, we had a population declining at about 4% a year. And in comparison to the moose reduction treatment area, the population was declining and stabilized. In my case, the caribou population was declining at 5% a year and then stabilized. Like, these are just glimmers of hope. It's not a panacea, but it's better than the alternative, all the other lambda values I showed you on the screen earlier. In Alberta, I love to contrast the social differences between our two provinces. In Alberta, there was very little thought about habitat protection. I should also mention that hundreds of thousands of hectares of old-growth forests have been protected in these areas, and I really hope I have time to cover that later. Yes, I should have time. In Alberta, no habitat protection, only the proximate limiting factor, only wolf control. So in 7 years, 841 wolves were removed here. Caribou lambda changed a little bit. It doubled recruitment. That was the main mechanism. So not particularly optimistic results. Now, there we go. Okay, so zooming into this experiment, I'm going to get into some details here. Okay, so back to the steps for recovery. These were the 4 steps. I added a few. I added, so scales and populations for recovery. I thought it was important at the time to properly identify your experimental units so that you didn't have movement between your units by caribou that would totally confound results. Estimate targets for recovery, so set some quantitative targets. In other words, how many moose would there have been had we not logged? So there's a lot more moose, like 5 times, 10 times more moose than historically. Make quantitative predictions. Model the system so that you don't make an irreversible mistake. Remove the agent of decline and then monitor. So scales and populations for recovery. As I mentioned, define some experimental units. We could use radiotelemetry. We used a combination of radiotelemetry and genetics and population genetics. And this was essentially, I'm going to go on a little bit of a tangent here just for fun. But this was basically our null hypothesis. If we have these 5 different ecotypes, so prairie caribou, barren ground caribou, boreal caribou here, southern mountain caribou, these deep snow caribou, and then these shallow snow caribou. One might consider these evolutionarily significant units, perhaps. They each have different foraging strategies. So these deep snow caribou have to eat lichen on trees. They don't eat lichens on the ground like every other caribou because the snow is 5 meters deep. Boreal caribou eat terrestrial lichens. These mountain caribou here eat lichens on windswept ridges in the winter. Prairie caribou, few small little stumpy caribou, and then, of course, barren ground caribou that can number tens and hundreds of thousands. So this is our null hypothesis, and if we challenge this hypothesis with some data, there's something weird going on. The story doesn't really fit at all, so I'll go back one. Am I supposed to point it somewhere? Yeah, go back one. And we find that the preconceived notions of these units aren't necessarily borne out. So, for example, my favorite example is these 2 subpopulations, which differ by only about 2 kilometers. You could throw a rock across their ranges. They don't move apart. The genetic distance, and again, this is using microsatellites, the genetic distance is as great between these 2 subpopulations as it is between, or greater than between these 2 subpopulations that differ by thousands of kilometers. And I start to thinking about why that might be, and you start putting population sizes next to them, and you start to think about drift and all sorts of, basically drift and those processes. And At a finer scale, we notice a lot of substructure, like an uncanny amount of substructure. And that's good from the sense of doing experiments, because you don't have migration. We did assignment tests and all that kind of stuff, and there wasn't much movement between these different subpopulations. 6 out of the 10 subpopulations around Revelstoke were demographically isolated. And the question is why? This is nothing too exciting. It's been shown across many taxa. Maybe the only cool thing is that the population sizes vary by 5 orders of magnitude, which lets you think a bit about process, so heterozygosity here. I think this next result is a bit more interesting. These are genetic distances corrected for geographic distance. So it's like a per kilometer genetic distance. It basically corrects for the confound that populations that are far apart would be more differentiated anyway, just by the factor of their geography. These are pairs of adjacent subpopulations, harmonic mean population size. And it seems like a huge driver of this genetic distance is simply population size. And I started to think more about how that would structure populations in general. And if you think about a population that numbered about 1,050 and it became fragmented for real. So we don't know why, it just became fragmented. You got this kind of pattern happening. And then you did what is classically done in landscape genetics. You retrospectively overlay GIS layers, let's say a highway and logging. And then you came back in 1 or 2 generations of these animals and measured their fixation index. You would probably find absolutely no difference between these putative subpopulations, because their allele frequencies are the same, because they're the population size, right? Drift isn't happening. Whereas here, you would start to see some kind of a small amount of fixation simply because of this small population size. And you would conclude incorrectly, highways don't fragment, logging fragments. So this is a little confound I thought would be interesting to point out in the world of landscape genetics. But yeah, back to the question. To conclude this section, we found that there was enough structure to assume that different treatments applied to these areas wouldn't be confounded by caribou movement. Caribou being the ultimate response metric, of course. Okay, so the next step was to estimate targets for recovery. We got to set an objective. We got to set a goal. We can't just say, less is better. So the question was, how many moose would exist had we not harvested the forest? So some kind of historic question before large-scale human intervention in the system. And I just used a rather unoriginal resource selection function, and just compared moose census locations to random locations, created a model. It was independently validated. It fit well. This is moose habitat in the winter, and then I backcasted using the computer. If you removed all logging cut blocks, this is how much moose habitat there would be. And, just the broad brush sort of sledgehammer approach is that there's 82% less habitat. I have to press less lightly. No, it's flicking on its own. Okay, so 82% less moose habitat. So the target, given that there's about 2,000 moose in the system about 15, 20 years ago, the target would be about 300 moose if we hadn't harvested. And there'd be about 206 that were estimated in 1984 from a BC Hydro survey that was done before logging in the area. Okay, so let's make some predictions now. Let's model the system. And why is this important? Well, perturbation experiments on these enormous scales are very risky. You might make a mistake that's irreversible. Ask the people with the lake flipping expertise. Getting that lake back from eutrophication is very difficult if you have a different stable state. Doing computer models is not risky, so we decided to use some predator-prey theory. And again, back to hauling. This is just an equation of logistic growth of the prey. So as the prey numbers approach carrying capacity, this becomes 1. The growth collapses to 0, so it's just sigmoidal logistic growth. This is the functional response, and that is basically the offtake of the predator. So the functional response, the number of prey killed per predator per unit time, multiplied by the predator's density, gives you the total offtake by the predator. Then what I did was added a second prey species, so this could be the moose deer, this could be the caribou. I made a 2-prey functional response. And then, of course, have the predator. So this is a system of differential equations. And so it's just basically a modification of Rosenzweig and MacArthur's classic predator-prey model. And then what I did was reduce the dominant prey by 82%, the target from the previous step, and explore the dynamics of the system. So reduce your prey, see what happens to the rare endangered prey. So, I mean, you can go on all day with computer models. They're silly, so you have to limit yourself. Yeah, sorry for modelers. Yeah. So if you reduce the primary prey by 82%, and the carrying capacity of your primary prey is about here, which is what the moose were, the prediction is that you will have quite a severe offtake by caribou. The caribou will become, the predators will switch to eating caribou. So that's a problem. You know, that's a problem if you want to reduce your invading prey. But what we also did was that was done in one time step, like 1 year. If you reduce that time step over, let's say, 20 years, and you play with the predator's time lag, we know that some predators lag sometimes by 1 or 2 years, you can mitigate the loss to caribou. You can mitigate the loss. So if the predator lags 2 years, you're going to lose about 20%, but you can mitigate that if you spread it out over time. Yeah, so that's the take-home of this analysis. Caution. You know, don't do it all in one time step. Of course, other simulations we did showed that if you reduce your prey, your moose and deer, and your wolves at the same time, that's the best approach. But that wasn't socially acceptable at the time. Okay, now what about the real world? That's modeling. Let's confront those predictions with data. And luckily, we had an accidental experiment, a mensurative or an observational experiment to test that prediction, those predictions about sudden versus gradual decline. And then we had the manipulation experiment, the moose reduction that we implemented. So let's start. Oh yeah, in many places in the talk I'm using catch per unit effort data, you'll notice, and I know those indices are fraught with errors, but when we can, we validate them. So yeah, hunter success is catch per unit effort. These are real population estimates, and at least in our systems we're finding that they correlate quite nicely, and I think it's always important to validate any assumptions or indices. So the perturbation experiment, this is Revelstoke, and this we get a lot of snow. Sometimes we get an absurd amount of snow. Is this just me, or does it happen to other people? Yeah, I'll do it slowly. Here we go. Okay, so 2 meters greater than the mean. These are average snowfalls that year. No, that wasn't the same year. I'd be faking data if I said that. The photo and this 2 meters. So it was even deeper than that photo. 1997, deepest snowpack we've had in the last 30 years. And what we saw is the white-tailed deer crashed suddenly, like by 80%. And everybody knew it. You never saw a deer anymore. What happened then? Cougar populations lagged by a year. Then they started to decline, of course, because there was no more deer. But the caribou population also crashed. So you reduced the invading prey, but that was a bad thing. We had no cougars eaten by caribou here, and then here we had cougars being eaten by caribou. Just before, the year before, and then after the crash, they switched. Now, good thing, this wasn't my idea, that just happened by nature, right? But it's a good, white-tailed deer shoot up, they crash naturally all the time. So it's a message, maybe keep your white-tailed deer at low numbers all the time. Use management to buffer against these natural fluctuations. All right, now what about the gradual reduction, the second experiment? So here was the design. We reduced moose in this 6,000 square kilometer area. This was our reference area, our control. And moose were hammered. Look at the massive difference in the treatment and control. So yeah, they were hammered, and it was a very controversial thing to do. It stalled out. We wrote a letter to keep the experiment going. It was. I just gave a talk to the Rod and Gun Club the other night, and they still hate me, but they hate me a bit less. In the treatment area, the moose reduction, moose numbers declined. They did not in the reference area. In other words, that was confirmation that the policy had its intended effect. It wasn't some kind of broad-scale climatic process that drove the moose numbers lower, which happens as well. So it wasn't confounded by climate or some other process. So let's hone in on the wolf response. So this is what happened to moose. Actually, Charlie's son did these censuses back. He coordinated these censuses in the 90s out of Nelson. And then this is when the treatment began, and we started counting moose annually. The wolf abundance declined. We think there were far more wolves here. We just didn't learn how to count them properly at the time. We had them radio collared, but the survey methods weren't perfected. But wolf numbers declined. This was the mechanism of the wolf response. It was dispersal. This was the dominant mechanism. They left the area. They mostly went north and east. They went into Alberta, where they probably killed them. A little bit of starvation. The main driver in the treatment area was dispersal. Adult survival in the treatment area increased by about 8 units, which is a lot for a case-selected organism. Like for a large mammal, going up from high 70s to high 80s is enough to create stability. They declined in the reference area. So again, we were able to document some responses to caribou vital rates. This is caribou recruitment in the treatment area and the reference area, basically unchanged. And I want folks to maybe think about why that might be the case, and we'll get to that later, maybe at the punchline towards the end. How am I doing for time? 34. What is that? 15 minutes or so? 10 minutes? Yeah. Okay. What about caribou population trends? So 3 subpopulations in the treatment area, 2 in the reference area. The smallest populations, regardless of where they were, continued to decline. I mean, look where we started with the moose reduction here. They were at 50. 50. These are at 120 in the national park. 120 down to 4 right now, over 15 years in the national park, in Revelstoke National Park. So the small populations continue to decline because of all the reasons we know about, extinction vortices and whatnot. The largest subpopulation stabilized, and even our most recent census showed stability. So we've got 13 years of stability here. Again, this is just a glimmer of hope. It's no panacea. This is not an ultimate solution, but it's one of the most stable populations out of those 65 in Western Canada now. And in the reference area, they continue to decline. Now, of course, the obvious question is, what are we missing? I mean, how do we go from stability to increasing? Do we adapt our hypotheses? Do we adapt our thinking? Let's see. Careful. There we go. Okay, so this is one option I haven't spoken about so far. It's kind of crazy. It's maternal penning. This is in Revelstoke. There's another one in Chetwynd. It's zoo management. It's not ecosystem manipulation, so it's not my love, but sometimes it's something you have to do to get yourself out of a bottleneck. So the idea is you put pregnant females here in March, they birth their calves in May or June, and then you let everyone go. You let them back go in the environment in July. So until the calves are about a month old, which is, of course, in ungulates, that's when they all die, is before they're a month old. That's when most of the mortality happens, especially with caribou. They die when they're young. So it's a buffer. I mean, I'd love to sick some grad students on all this stuff, foraging ecology and, all that kind of cool stuff, and survival rates, and but this comes to me, when I think about this as nesting treatments. Of course, some might think about it as confounding, and I remember when I took Carl's course in 95, I think it was the last or second to last class, like, how do you deal? You can't keep doing factorial experiments on these scales. Oh, let's just pen here, and it's impossible, right? Because the scales are enormous. It's not a petri dish that you can replicate and do factorial treatments everywhere. So nest the damn things. Do some good science, complement it with good mathematics to try and figure out the relative contribution of, let's say, penning versus predator control or versus moose reductions. Huge community support. This is the one thing everybody loves, even though the response can be quite muted, because it's, look at the little baby. It's so fun. Lots of support among First Nations. The ski hill Lexus collect lichen and ski for free. So back to this slide, back to limiting factors. Okay, so we've got very modest responses to our experiments. How about when we pull a couple of levers? This is the one case where we've pulled a couple of levers. This is my colleague Scott McNay here. First Nations-led recovery program. The wolf control plus the penning has provided astronomical results. They've doubled their herd. It's unprecedented in Canada. He hasn't published this yet. So I don't want to steal his thunder, but it from 32 to over 60 caribou in 3 years. We think most of it is due to wolf control, using that math, partitioning, survival and all that stuff. But it seems to be and I should have mentioned, yeah, so I'll give away the punchline. The penning protects predation from bears. Bears kill babies. You can't kill bears. No one's going to reduce grizzly bears, of course. So, yeah, this is dealing with multiple limiting factors, multiple predators, and it's a stronger glimmer of hope. As I said, it's unprecedented, and I hope it continues. They may stop the penning in 1 year to help tease apart the relative contribution a little more experimentally. And from day one, their recovery plan, the First Nations-led recovery plan, focused on habitat restoration as well. They were doing those measures as an emergency measure to stop the bleeding, to get through the bottleneck, to get some breathing room, and then get buy-in for decommissioning roads. Roads, of course, provide highways for wolves to scream. The wolves run 3 times faster on roads and they kill more. And going beyond just deactivation into the idea of restoration. It's $10,000 per kilometer. None of this is cheap. Just a tangent again, in Alberta, in the oil sands area, there are 105,000 kilometers of seismic lines. So do the math, $10,000, that's over $1 billion. That's the price tag on that. And to do the habitat restoration. I promised I would talk about habitat. I hope I still have time. Because, people always slam us. All you guys are doing is killing things. What about the ultimate cause? So I do like to criticize silly decisions by the government, but some credit has to be given to the hundreds of thousands of old-growth forests that have been protected. In the 1990s, the land use planning strategies began, and that was in response to the Brundtland Commission, 1987, the UNESCO Brundtland Commission that said, protect 12% everywhere across the world. And at that time, BC was at 6%. In 1991, the NDP actively campaigned on going from 6 to 12%. That was an active campaign promise. And then that's what precipitated land use planning in the province. Alberta's just starting. They've been killing wolves for 20 years, but they just began their habitat land use planning. At least in BC, we began that in the 90s. Yeah, I'll never get a job in Alberta either, I don't think. Yeah. So, no harvest up high. In the spruce fir forests, it had to be 30% old growth plus a modified cut, and 40% protection in the cedar hemlock forest. And again, like each hectare is worth like $500,000. Like these are pumpkins, right? These are massive trees that are shipped to Vermont and Japan and such. Most companies just defaulted to this rule. And again, this had to be of the potentially loggable forest, not just any forest. So what that looks like on the landscape, so this is all forest here, but the blue, this light blue, is the potentially loggable forest. This is forest, but not loggable. It's too steep and such. From the 1990s process, we grabbed a bunch. This is the budget we were given. We grabbed a lot of forest for protection. That was my job for about a year. It was incredibly boring, but it was applying the research we collected. So this burnt orange is what was locked up, so there's no logging. They're essentially parks. And then in 2005, there was another round of protection, another 10,000 hectares. And I should say I'm showing the worst. In Prince George and down in the Purcells by Nelson and Kimberley, they've protected 99% of the habitat, but that's because the caribou live a little bit up higher there. Here the caribou conflict directly with forestry, their habitat needs. So up north and down south, it was easy pickings, everything was protected. They say their goal is to protect 100%, but it's possible, but you would be putting 4 logging companies out of business in Revelstoke and Blue River. And then this light green is what's left to harvest. So what's the take home here? It's been nuked. It's been heavily harvested. Obviously, these are all old cut blocks, right? Existing forestry. It's been heavily harvested, but most of what's left is protected. So it's a dual message there. Heavily logged, but most of what's left is protected. University of Maryland has this nice Global Forest Watch program, and they classify forests into 3 categories. Existing forest, the red is young forest, like fire or logging, and the blue is regenerating forest. And if you zoom in on the central interior of BC, you see that there's a lot more blue and green, like regenerating forest, than red, than new cut blocks and new fires. So, maybe these protection measures are having an effect. This is, again, a small glimmer of optimism. What else did I want to say here? Probably that's it. I'm forgetting something, but it doesn't matter. Ooh. Yeah, lots of other stressors on the landscape that I don't talk about. This is real in Revelstoke. That's a real, yeah. This was the same place where that big avalanche came down 5 years ago and took out a bunch of sledders. No one, yeah. These are snowmobile closures. And I guess, yeah, I forgot to make the point here. If caribou go extinct, all this disappears. These snowmobile closures disappear. The old growth forests disappear. So if you really care about biodiversity, there is no other lever that covers such a huge area in the boreal forest across Canada or in our central interior rainforests. We used to think grizzly bears were the best umbrella, but we've learned that, yeah, you can log like crazy and grizzly bear populations will still do fine as long as you don't submit them to lead poisoning, like shooting. Yeah, grizzly bears can just churn along right through harvest, but not so much. So really, caribou, there is no white knight, there is no endangered forest legislation. It's endangered species, and there's no other species that cover this kind of scale to conserve. I mean, there's thousands of species we don't even know exist in these old forests, right? There's lichens, there's cryptogams, all sorts of fuzzy little things, and yeah, this is the tool. So what's the next experiment in the cycle of adaptive management? What are we missing? What are some things we can do to help get this stability increasing? A few stable populations. Well, I think we already know the answer to that. I think we do. I'm plagiarizing Charlie's textbook here, who is citing Graham Collier. And the salient point is, yeah, several agents of decline may have to be removed at once. It is better to save the species than to achieve scientific purity. That's the bottom line. Oh, Dolph, you're chuckling?
It's classic, Charlie.
Yeah. Yeah, so I have an unoriginal recommendation for the next experiment. Pull all 3 levers at each trophic level simultaneously. Habitat, invading prey, reduce the predators and invading prey concurrently until that blue becomes green on that Maryland map. Of course, I'd be remiss if I didn't acknowledge my co-authors. I don't think I've published a paper in the last 15 years without one of these 2 folks. Stan was my PhD supervisor. Bruce is the MOF researcher. If you want another nice applied talk, Bruce has some brilliant experiments with grizzly bears. The hunt was just banned in BC, the trophy hunt. He wrote a paper in Journal of Wildlife Management on sustainability of grizzly bear harvest just like in November, which sort of foreshadowed the closure. Very nice experiments in the southeast of the province where there's food, no food, hunting, no hunting, logging, no logging. Beautiful factorial design to help tease apart top-down versus bottom-up factors on what limits or regulates grizzly bear populations. And then, so many people, funding agencies, thanks to my colleagues for letting me poach their Clinziza maternal pen results up in Chetwynd. And I think with that, I'd love to take some questions.
First one from Carl Walters.
Hi. Howdy.
The most data you showed there was a possibility that compensatory calf survival pattern that we've seen for a long time and always attributed to wolves might actually be due primarily to persons.
Maybe.
Haber used to claim that. We just laughed at his analysis of the last.
So the compensatory pattern on the population growth rate there? Can I explain what we think is going on with that one? Okay. We put a follow-up paper out on that one in ecology, drawing on so much functional response theory. And imagine this. Imagine you have 10 groups of 10 caribou. Predator comes along, kills 1 caribou from one group. Still got 10 groups of 10. Comes along, kills a caribou from another group. And so on and so on. You still got 10 encounterable units. But the per capita predation rate is skyrocketing, hence the compensatory effect. So we think it's a grouping thing. That's what we think. It's just an encounter thing with numbers of groups out there. We think that's what's causing the Ali effect. And we have some data to show that group size is declining at a slower rate than population size. So, yeah, I mean, obviously we don't have an experiment for that one, but that's what we think is going on. I mean, you can argue about the details. Oh, a smaller group is less encounterable, but we're talking about woodland caribou here. It's not these huge barrens.
Radio color data suggested the approximate agent calf color
We don't. So the calf studies are extremely rare, and you can imagine why. The difficulty in capturing neonates is near impossible. There's about 3. There's Lane Adams' work in Alaska. There's an unpublished study that McNay did, the Penning guy from Chetwynd. He's got to publish that thing. And there's 1 or 2 more, and I've summarized them. And the wolf mechanism is not that strong. It seems to be bears. One study out of the Musqueca Chica showed wolverine, but that study only lasted. And you got to watch the denominator on these things, because just because you say, oh, wow, 4 wolverine killed our caribou, or 4 caribou were killed by wolverine in the first month. What about the next 11 months? So you're bang on. The next 11 months is probably wolves. But the radio collars fall off after a month. You're going to strangulate the calves, right? So, yeah, exactly. It's always your changing denominator for these vital rates.
Keeping in mind that habitat is a driving factor, have other ways of limiting wolf populations been considered? For example, birth control or viruses?
Yes, twice. One was in Yukon. Bob Hayes had a master's student do sterilization. The results were muted. I mean, you still have these guys out there. The idea is you sterilize the dominant pair, you kill the rest, and then that dominant pair still maintains a territory. And then it was tried in Williams Lake by Randy Wright, and again, really ambiguous results. Yeah, it's a tough game. I mean, if you want to get on the wolf game, you have to kill them all. And even then, you only ever drive the population down by 80%, because that Alberta thing, like, it's flat in Alberta, right? So they come in like crazy. And that little Smoky, that polygon was maybe only 4,000 square kilometers. So 841, of course, you're getting immigration big time. So it's working better in the mountains because you have closure. But those other tools, they've been tried and they've given it a good go, but it's just not working. Closing Moline Lake and that. Yeah. No. I mean, that's gonna stop one wolf from moving on a road, but it really isn't dealing with a population-based limiting factor. That might help in the long term. That's like that road deactivation thing. That's not going to have any effect for decades, and the scales are just all wrong. You have to go big. Yeah.
So that super depressing map with all the red was below.
Yes.
May I assume that they would just continue on to extinction if nothing's changed, or is this just maybe a climate change effect that's reset carrying capacity and they're going to asymptote to different smaller populations?
Excellent question. Did everyone hear it? Yeah. Yeah, so I mean, those differential equations I use do just that. They are equilibrium-based models, but we also did some stochastic, I don't know if stochastic's the right word, but we looked at transient, that's the word, transient dynamics like that. And no, because we have extinction happening all the time. Like Banff went extinct, whatever it was, 5 years ago, and Avalanche took the last 5 out. Columbia South is down to 4. It's not a new low. There's just too many overlapping limiting factors. I mean, the people have done those population viability analyses, and that's, of course, what Graham Collier railed against. Let's not worry about that stuff, focus on the agent. But, I don't think there would be any support for that. It's been 20 years, right? A lot of these herds have been studied for decades, and they're going down, except for the levers, the ones where we've pulled some levers hard. Louis?
You haven't mentioned anything about climate change, no? The whole thing that
I forgot to mention climate change. Yeah, I mean, of course I forgot, because it's, So I just showed logging that increases moose and wolves. But climate change, logging increases moose and deer. Logging increases whitetail deer. And Kim Daw has some excellent work out of Alberta showing that, the 20-year trend has been less severe winters, less snowfall, less cold, and the deer populations are exploding. I mean, you're getting deer in Northwest Territories now, whiteys, so yeah. Oh, yeah. I mean, yeah, these are going to be a conservation-reliant species for sure, but I mean, the only optimism I have is Clinziza, that lambda of 1.2 there. Yeah, I mean, what else are you going to do? I mean, that's in an area, and that area is nuked by logging, that lambda of 1.2. So again, that's another strike against the food regulation hypothesis. You remove bears and wolves as a limiting factor, and the populations grow. Yeah.
Rob, I'm thinking about the smallest populations, and from your moose reduction experiment, you indicated the small populations were too small and that couldn't recover them, which makes me think of the arguments for triage that you see a lot now around caribou, like Mark Cowboy's paper. But then your Chetwynd example was a very small population that seemed to recover well, and you said that was largely attributed to the wolf control. So I guess my question, why did it work some small populations and not others? And then what are your thoughts on the argument for triage?
I love that question because some of the small populations down by the U.S. border are surrounded by agriculture. So you will have a permanent pump of deer and cougars down there. It's permanent land conversion. So in my mind, the argument for triage is much stronger down there. Whereas in Chetwynd and north of Highway 1 and Revelstoke, etc., there's no human settlement. So those forests that are blue will eventually be green again. So there's the hope that can be managed in such a way. And as I mentioned, there's huge logging constraints up around Prince George and such. So I wouldn't make the triage argument for small populations up there because of the ultimate changes. But triage down by Nelson and Kimberley, I mean, you're going to be killing wolves and cougars forever there because you're never going to get those seral stages back in terms of the vegetation of that trophic level. It's young forever because you got wheat and barley and such, yeah.
Take my position up front here to ask another question and just say you showed that we could control the moose by hunting as a potential. What about white-tailed deer? I mean, they're notoriously difficult to control for a hunting mechanism. Is climate change and changes allowing them to increase? Can we use that?
Probably not in Alberta, where there's limited access in the oil sands and where it's just flat and they're everywhere. But in the mountains, yeah, give me a February season and I'll take them all. Like, it'll be easy because they're all pushed down to the valley bottom, right? They're all within 200 meters of the lake. We'd have no problem. My son and I just took 2 deer out the other day, and sorry, I don't mean to be a redneck, but it'd be easy if you had no bag limit in the winter, and it's just do the policy work on that front. We got shut down for that bag limit last year, and you just. There's huge social impediment for that, but because, you're killing females and you're doing it in winter, this is crazy talk, but if you care about it, that's what you do.
Great, well I think we've got to just about 1 o'clock here, so before we thank Rob, I'll just say that he does have some time after the grad student lunch to meet with folks if anybody wants to grab him, either coming out of 54 or sometime in there, and also still some room to join us for the pizza and beer tonight at John Richardson's house. I didn't send around the address, but if you want to come, just grab me to get it or shoot me an email. And we'd love to see you there to continue the conversation with Rob. And please join me now in thank you, Rob.
Thank you. Thanks, Cole.